Hello everyone, we are Group 12. In this video, we will introduce our final project, Transformer Music Gen. We will try to talk about why we choose this topic, history of the problem, and its relevance to modern-day applications. We will also show the visualization of the results and the music we generate. At the end, we will talk about what we learned from this project. Without further ado, let's welcome the show.
Hello everyone, we are Group 12, and our topic of our project is Generating Music with Transformer. Introduction. What is AI-generated music? AI-generated music refers to music that is composed with the help of AI algorithms. Essentially, it involves using computer software to analyze existing music and then generating new compositions based on that analysis. The process usually involves feeding a large data set of music into an AI algorithm, which then analyzes the patterns and structures of that music to create its own original compositions. The history of AI in music composition can be separated in three parts: the early development, evolution of techniques, and current landscape. The history of AI in music composition dates back to the mid-20th century, with early experiments focused on algorithmic composition and music generation. The evolution of techniques. Over the years, AI in music composition has evolved from basic role-based systems to sophisticated machine learning models. In the current landscape, in the modern era, AI has become an integral part of music creation, contributing to diverse genres, styles, and productions. The Iliac Suite. The Iliac Suite, a groundbreaking piece composed in 1957 by Jaron Hiller and Leonard Isaacson, is often cited as the first example of AI-generated music. The Iliac Suite was created using an early computer called the Iliac-1 and was based on a set of rules derived from traditional music theory.
Okay, so I'm going to talk about why we choose the topic. Music has always been an indispensable part of human life, evolving into various forms across centuries and different regions. In this era of prevail AI development, we are curious about the sparks that will be ignited when music intersects with artificial intelligence. AI-generated music applied in various industries, and we can separate it into four parts, the first one being media and entertainment. AI-generated music is widely used in films, video games, and multimedia productions to create immersive soundtracks, ambient background music, and interactive audio experiences. The second one being advertising and marketing. Marketers leverage AI-generated music to create custom jingles, mood-based soundscapes, and brand-specific sonic identities for effective advertising campaigns and brand promotions. The third one being therapeutic and wellness. In therapeutic settings, AI-generated music is utilized for relaxation, stress reduction, and personalized music therapy, catering to individual preferences and emotional well-being. The fourth one being education and training. AI-generated music is integrated into educational resources, e-learning platforms, and training modules to enhance learning experiences, music exploration, and creative expression in diverse educational contexts. And the benefits of AI music generation will be separated into three parts. The first one being creativity enhancement. AI-generated music expands creative boundaries, offers new inspirations, and enables musicians to explore unconventional music styles and experimental compositions. The second one being efficiency and productivity. AI tools streamline music production, automate repetitive tasks and optimized workflows, leading to increased efficiency and productivity in the music creation process. And the last one being customization and personalization. AI-generated music allows for personalized music recommendations, tailored compositions, and adaptive musical experiences that cater to individual preferences and tastes.
And we introduce the background of the AI generated music. So we need to practice the AI generated music. Okay, the method or used in AI generated music is called transfer architecture. Transfer models have demonstrated effective in encoding music representation and generating complex musical patterns, and they have the capability to handle long-range dependence and produce device musical composition with rich and intricate arrangement. And the methodology is divided into the three parts. The first part is called data processing. And first, we use ABC notation, and it will introduce later, and to read the training data set. Then we do several processes such as cleaning and data cleaning. We need to split our set of melody with different number of bars to set of melody with 16 bars, 8 bar input and 8 bar to target at each other, and unavailable data and remove long silence. And you can to set long silence by token X8. It's using, for example, at the intro. And removing silence from the data is boosting precision. And the last is called removing repeating. And removing repeating, we find that remove sample where has so many repeating of the sample note at target bar. It made the model small device. And L we use down in the part M to improve our model to generate more diverse melody. And the second part is called model training. After data processing, we're able to train our data. We use the transfer to sequence and sequence translation and train the model with this processed data set. And the third part is called generate the critical node. After the training of the model, we can start generating music with given input.
So from the above, we know we use ABC notation to deal with the data processing. And here is some feature about ABC notation. It is a shorthand form of musical notation for computers, and it contains information about notes, rest, speed, and others. And it is originally designed for single voice melodies, and it using ASCII characters to imitate standard musical notation, and it can be easily edited and encoded since it is ASCII code based. And here's an example of ABC notation. On the above, we can see it transforms the first four notes into F2, G2, A2, and F2. The F means the key of the notes, and the 2 means the length of the notes. And the after notes are the same. And second, we know we use the transformer to deal with the model training. To talk about the transformer, we know firstly we get some text to the input, then you transform input text to the sequence of tokens. Tokens are numbers that represent some part of text like words or n-grams. We are pushing this token into encoding part of transformer model and getting hidden representation of input text. This hidden representation is pushed into decoding part that's generating new and new output tokens based on hidden states and tokens that was generated before. We are converting output tokens into text and getting the output of our translation model.
And let me introduce our code function explanation. And this is our first function I want to introduce. It's called read ABC. Here, after we pre-process the data set and transfer into ABC notation, we have to load our data set. And as we mentioned before, we have to pre-processing the data set. So here we remove some non-important characters such as spaces, tabs, and next line symbols, which is unnecessary for our ABC notation. So the code is like the right side. And the second function is get model. Here we use the transformer model, and it's a model called BERT, and we load it from the Python library. And here we use the library is from the Hugging Face Transformers library. The third one is predict nodes. Firstly, we will tokenize the keys and nodes, and we have the if condition to ensure that the total length does not exceed the model's maximum input length. And after that, we will create context tokens, convert it to a PyTorch tensor and unsqueezed to add a batch dimension and put it to our model. And after that, we will use our model to generate a sequence of tokens with several given parameters, including the input sequence maximum and minimum length, early stopping stating, number of beans, start and end tokens, and etc. At last, the generated token sequence will be converted to a list and decoded using tokenizer. And after that, I will introduce how we tokenize, how we train a tokenizer. And we will use a tokenization called byte pair encoding, and we use the Python library called utoken2me. This approach will allow for a more flexible representation of relations between nodes and chords, since we all know that some chords is you have 3 or more nodes at the same time. It's called the chords, and we will use the byte pair encoding to deal with the chords. And this design will enable the model to better understand and generate sequence with rich musical structures. And the last part is training. Since the Hugging Face library have the training loop for sequence-to-sequence models, so we actually use most of the library from the Hugging Face, and it's like the right-hand side. Here, we only build batch from list of samples, dataset, and model objects, and also set some training parameters like batch size and numbers of epoch, and etc. And here we train 100 epochs on V100 for 6 hours. And this is our result. The first 30 minutes is our input sequence, and our model will generate the music like this. And that's our demonstration of our model.
Okay, hi, it's me again. I'm talking about future work. And there are many challenges and limitations of AI music composition, and we break it into 3 parts. The first one is the data bias and quality. Challenges arise from biased training data and the need for high-quality datasets to ensure accurate and diverse AI-generated music that transcends predefined patterns. And the second one is creative authenticity. The quest for preserving creative authenticity and artistic integrity with AI-generated music raise questions about originality, emotional depth, and human touch in compositions. And the last part is ethical considerations. Ethical dilemmas surface regarding copyright infringement, intellectual property rights, and the responsible use of AI in music creation, distribution, and attribution. And the future trends and advancements in AI music technology, there are many parts of it, and I'm going to talk only 3 parts of it. The first one is interactive music generation. The future of AI in music technology revolves around interactive and cooperative music generation systems that merge human creativity with AI's computational capabilities to expand artistic expressions and musical collaborations. And the second part is emotional intelligence in music. Advancements aim to imbue AI-generated music with emotional intelligence, empathetic responses, and contextual awareness, enhancing the emotional impact and resonance of musical compositions. And the last one is AI music co-creation. Collaborative co-creation platforms and tools will facilitate seamless integration of AI-generated music with human musicians, fostering new genres, experimental compositions, and novel musical experiences. And the last part is our reference about AI-generated music, ABC notation, and the transformer. And this will be the end of our presentation. Thank you.